Finally, for exercise 4, which is about electromagnetic waves, we are given that an electromagnetic wave emitted by the sun takes 8 minutes and 20 seconds to reach the earth. So the period of this wave is given also to be 2 times 10 power minus 15 seconds. Given that the range of frequencies of the visible electromagnetic waves is 3.75 times 10 power 14 hertz, and we say in the order of 10 power 14, and 7.5 times 10 power 14 hertz. You have to actually to memorize this range. And the speed of electromagnetic waves in vacuum is C equal 3 times 10 power 8 meter per second. You are also supposed to memorize this value. You are supposed to memorize the speed of any light wave or any electromagnetic wave in vacuum. And otherwise, if you are given electromagnetic wave propagating in a medium other than the vacuum or the air, like in water or glass or so on, you will be given the speed. So now for one, calculate the wavelength of this wave. How shall you think about it? In order to calculate the wavelength, I have to make use of the given. The wavelength is related to the speed and the frequency according to the formula V equal lambda times f, or to the speed and the period according to the formula V equal lambda over period. But you are not given the frequency, you are directly given the period. So you have to make use of this formula. Its origin is actually the formula V equal D over delta T. But considering one cycle, the distance covered is lambda and the total time needed is T period. So doing a cross multiplication here, lambda is V times the period. We are given all the values in the SI unit, that is the speed in meter per second and the period in seconds. So 3 times 10 power 8 meter per second times 2 times 10 power minus 15 second is 6 times 10 power minus 7 meter. Calculate the frequency of this wave, then deduce whether it's visible or not. We are given the period, frequency and period are related by the formula F equal 1 over T. 1 over 2 times 10 power minus 15 is 0.5 times 10 power 15 hertz. Now, why didn't I stop here? Because they asked me to deduce whether it's visible or not. This means that I have to compare the value to the given range here of visible light, to this one here. Okay, I have to compare it to the range of visible electromagnetic waves. And as I can see, I'm given the limits of this range by the order 10 power 14. And here I got the value in 10 power 15, so I cannot compare so far. 10 power 15 is actually 10 power 1 times 10 power 14. So as if I have 0.5 times 10 power 1 times 10 power 14. So 0.5 times 10, we get 5 times 10 power 14 hertz. Now, yes, we can see that it is visible since 5 is greater than 3.75 and less than 7.5, but I allowed myself to do this comparison only because we have the same order here, times 10 power 14 hertz. So yes, visible since 5 times 10 power 14 hertz is within the visible range of frequencies. Calculate the distance between the sun and the earth based on the given information. We are given that this wave needs 8 minutes and 20 seconds to reach the earth, so it covers a certain distance. Now I have first to convert the total time into SI unit. Like here, the 8 minutes we multiplied by 60 to convert it to seconds, because every 1 minute is composed of 60 seconds. So delta T is 8 times 60 within parentheses seconds plus 20 seconds, we get 500 seconds. Now applying the formula V equal D over delta T, because this wave propagates at constant speed in the vacuum, so we can apply it. Then D equal V times delta T. We are given that the speed of light in vacuum is 3 times 10 power 8 meter per second, and we know that the distance between the sun and the earth is considered to be vacuum. It's in the outer space. So we use this value times 500 seconds, we get 1500 times 10 power 8 meter.